hello, Mr. Eric, Mr. Ryan, are you right?
Yeah.
Okay.
Pardon me.
So we're given a pizza, or the pancake, or whatever. Okay, or mooncake, a cake.
A mooncake's not round.
The question is that we're given a circle, a shape of circle, which could represent the cake and
You could just say
pizza.
You could just say circle.
Okay, so we can cut it, right? When we cut it, it has to be through the circle. So it has to be something like touching the points of the circle. It can't be like something like that, right? It can't be partial.
Does it have like both sides has to be like the same?
No. Okay, that's a good question. Now I do a one cut. How many pieces?
2.
Okay, so the question is that if I ask you to cut it n times, how many pieces, maximum number of pieces you can get? For example, 1 cut, 2 pieces, right? 0 cut, 1 piece, right? 2 cuts, how many pieces?
4. Oh yeah.
Okay, another cut, how many pieces? So let's just use the f function, right? F0, 0 cut is obviously, no, F0 cut, how many pieces? 1, right? If we don't cut, it's 1 piece. If we cut it one time, 2 pieces. If we cut it 2 times,
7. Oh yeah.
if we cut it 2 times,
7.
4 pieces, right? Cut it 3 times.
Like here.
Yes, how many pieces?
7.
1, 2, 3, 4, 5, 6, 7. 7 pieces. F4.
If you cut it all through the center, it'll just add. Yeah. But if this little triangle here, it'll make if you put it like over here.
Yeah. So we don't want to cut it to the share point, right?
Mm-hmm.
So for example,
Wobbly line.
So for example, you don't want to cut through the center, right? If you cut through the center, it's not maximum, right? How many? 1, 2, 3, just 6, right? If you cut another one, it just increase 2. This is the least optimum way.
Can you make a wobbly line? It's
No.
not the least optimum, but this is the least optimum.
Oh, okay, yeah, you're right, yes.
Can you cut it and then cut the same bit over again?
No, okay, that's why I'm saying no. Okay, so this is the least not optimum. This is okay, but not the optimum. This is the optimum. Okay, so I was saying F3, consider the F3 and F2. So now this is F2, right? So F2. So why we choose to cut it this way?
Because we can make an extra little triangle in the middle.
Okay, how about F4? How to cut the F4?
Is it? I don't know. Is it like maybe here? No.
Yes.
Is it like here?
Okay, so how many?
Because
I'm here, right? Yeah. Yes? So how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right?
Yeah.
Okay, so do you find the pattern here?
Is it correct?
Yes. F5 equals what? Can you keep
It's
going?
basically 1 at 1.
Do you find the pattern?
1 at 2 at 4 is 7, right?
Yes.
4 and 7 is 11. But
Okay, so do you find the pattern here? Do you find the pattern? So what's the distance here?
1,
What's the distance?
2,
What's the distance?
3,
What's the distance?
4,
What's the distance?
5,
So what's this?
16.
Yes. So why? Because look, Fn, right? Fn, this is the nth cut. Obviously it's the base on the number Fn minus 1, right? Yeah? Plus what? Here, plus what? So Fn equals, now I'm cutting the nth time. Then the number of pieces I can get is obviously previous one, Fn minus 1. Plus what? Look, this is the first cut. The second cut, how many more pieces can you get? Okay, look at now I have two pieces. I want to cut the second time. How many more pieces can we get?
2.
2. Okay, so now we get the n more, right? Now I want to cut the third time. How many more pieces can we get?
3.
3, yes. Okay, so do you get it? So every time I cut the nth time, so the number of pieces I can get additionally is n, right? Because ideally this line needs to touch, needs to increase, needs to cause more, n times more pieces. So it's Fn minus 1 plus n. Okay, f5, look, f5 equals f4, which is 11, plus 5, 16, okay? f6 equals f5 plus 6, which is 16 plus 6, 22, okay?
Yeah, but if you do that way, you might not know what's fn minus 1, so you have to do the problem again.
Okay, so that's true. fn equals fn minus 1 plus n. What's this? What's this?
Fibonacci.
It's not Fibonacci, it's similar. So what do we call it? If we want to solve the fn, we need to solve the fn minus 1.
Dynamic.
Program, yes, but look at this equation. Yes, look at this.
Realization.
Yes, all correct, all correct. It's related, all correct. What I'm saying is that look at this. fn.
Research.
No, come on, listen to me.
Research.
No. If we want to solve fn, we need to solve fn minus 1. If we want to solve fn minus 1, we need to solve fn minus 2 until we reach f0. So what do we call this? Start with R, E,
Reionization.
C, U.
Recursion.
Recursion, yeah, calling itself, yeah. Remember the Fibonacci, fn equals fn minus 1 plus what? Replace this with fn minus 2, am I right? Recursion. Okay, so we can just solve this using recursion.
Or depth search.
I mean, not necessarily the first search. This one is pretty straightforward, okay? Define fn. If n equals 0, return 1. Otherwise, return fn minus 1 plus n. That's it. This is the Python code to implement this. Obviously, the n needs to be positive, right? So we need to assert n bigger than 0. Okay, what happens if I don't specify the assert, and if I say f minus 1, what will happen? If I call this function f minus 1, what will happen?
It doesn't know what to subtract, so you think it's a negative number.
Yeah, look, f minus 1. Is it equal to 0? No. Equals f minus 2 plus minus 1. F minus 2 equals f minus 3. F minus 3 equals f minus 4. It keeps going, it never ends. Right? It never ends. So this will cause you stack overflow. Stack overflow. If I call it f3, any positive number, f3 equals f2 plus 3. f2 equals f1 plus 2. f1 equals f0 plus 1. Here, f0. What will happen f0? If n equals 0, yes! We are waiting for this, right? N is 0, then simply return. It won't cause any further cost. We know how to solve this f0, which is 1. 1 plus 1 equals 2. Right? So f1 equals 2. 2 plus 2, 4. 4 plus 3, 7. Okay, so we get it. f3 is 7. Okay, this is recursion. We can put
All one line.
cache, okay? So this is top down. Bottom up, f0 we know is 1. f2 we know is the previous one plus n. Right, then we can calculate this way until we reach fn, right? This is called bottom up. Top down is this way, okay? It's not very intuitive, right? Top down and bottom up, it looks like the opposite, but this is what we call it. Because why is it top down? Because if you want to get the fn, right? If you want to get the fn, just call it, and then it top down, it calls the fn minus 1 until f0, right? This is top down. Bottom up is this way, right? If you know f0 and
So like
yeah.
with n is 0.
If the n is 0, then return 1. This is the terminal case for the recursion. Okay, so this is recursion. Now we solve it using two different approaches. Right? We talk about that many times. Okay, so today we're going to solve this using mathematics. So do you wonder, how do we solve this? What's the equation? You know, just given n. Given n. We want to calculate the value, right? For example, the problem with this Python code, right, recursion, top down or bottom up, the time complexity is O(n), right? Yes, O(n). Why is O(n)? Because if I throw you a number n, Fn, you need to calculate Fn minus 1, Fn minus 2, right? There are n iterations, recursion, right? Even for bottom up, right? You calculate from F0, F1 until Fn. This is O(n). Do we have O(1) solution? Yes. We call it math.
Of course we do. Otherwise, why would you suggest it?
So This is, let's plot it. What do we call this? If we call this is n.
Graph.
N, yeah, graph, yeah?
Yeah.
Axis. This is n, right? This is
The
Fn.
quadrant.
Yeah, okay. F0 is 1, right? F0 is 1, right? Okay, F1 is 2. Here is 1. F1 is 2 here. Okay, so F2 is 4, right? F2 is 4. Okay, F3 is 7. Okay, 7 might be here. So if you connect the point, okay, something like that. It's not a straight line, right? It's not a straight line. Definitely not a straight line. What's a straight line? Straight line is something like that, right? Straight line. That's a straight line.
Or it could be like.
Yes, that's a straight line, right?
Or it could be like 01.
Obviously, it's not straight line, right? Because if you plot it, it's not straight line. So this is a straight line. Straight line, we know the equation, which is ax plus by equals 0, okay? Or equals c. These are a, b, and c. These are constant, right? These are the knowns. This is ax plus by plus c. For example, this one is passing through the 0. This is y equals x, right? So actually, this is what? X minus y equals 0. So the a is 1, b is 1, c is 0, right? A, B, C. So
Is C always 0?
no. When it's 0, it's passing to the 0 point. So when this is 0, when x is 0, y must be 0, right? Am I right?
Yeah.
So it's passing through the 0 points. 0, 0, this is called origin point. Right? If c is not 0, then it could
Then
be,
you said like x equals y.
yes, y equals x, actually. Y equals x. Okay?
And what if like the line isn't like going through the 0 point?
What do you mean?
For example, it might be air.
Oh, you mean here, right? So here, right? This is, what's this value? For example, this is minus 1. Okay? Here is 1. Here is 1. So this is y equals x minus 1. Look, when x is 0, y is minus 1. When x is 1, y is 0, right? X minus y minus 1 equals 0. Okay, so a is 1, b is minus 1, c is, actually you can arrange this plus c equals 0, okay? So c is minus 1, okay? This is a straight line equation, okay? This is y equals x squared. When x is 0, y is 0. When x is 1, y is 1. When x is 2, this is 4. When x is 3, this is 9, okay? This is minus 1, 1, minus 2, 4, okay? For x squared, right? You know it's a symmetric. Minus 2 squared is 4, right? So minus 3 squared is 9. 3 squared equals 9. So x squared equals minus x squared, because minus 1 squared is 1. Okay, look, x squared minus x squared. Minus 1, this is minus 1. Minus 1 squared. Minus 1 times minus 1. Double negative is positive. Ax squared. Look, this is 2 times. Quadratic, we call it quadratic. Plus bx plus c equals fn. Now let's plug in the point when x is 0. So there's 0 plus c equals 1, right? So we know c is 1. Okay, c is 1. Now let's plug in 1. 1 is a plus b plus 1 equals 2. Okay, now let's plug in 2. 4a plus 2b plus 1 equals 4. Right? Okay, now let's solve this equation. 2 equation, 2 unknown. We plug in the points. Look, we plug in the points. And now we have 2 equation, 2 unknown. Let's solve this. Times 2. Subtract from 1 to 2. 2a minus 1 equals 0. What's a?
0.5?
A equals 0.5. What's b? Originally is a plus b plus 1 equals 2, right? A plus b equals 1. So a is 0.5. What's b? Also 0.5, right? Okay, so what's the equation? So what are we looking for here? So the equation is 0.5 times x squared. Okay, x is n, right? N squared plus 0.5 times n plus 1. This is Fn. Can we verify? N is 3. When n is 3, F3 equals 0.5 times 3 times 3, 9, plus 0.5 times 3, 1.5, plus 1. What's the answer? 4.5 plus 1.5, 6 plus 1 equals 7. F6 equals 0.5 times 6 squared plus 0.5 times 6 plus 1. What's this answer? 36 times 18 plus 3 plus 1. 22, right? Yeah. Okay, so we have this equation and we can just say define Fn. Return this, right? 0.5 times n or n star 2 or power n2 plus 0.5 times n plus 1. Right? Okay, remember the previous one, top down, bottom up, the recursion, minimization, dynamic programming, all those fancy words you just shouted, alright? And this one, which one is the most efficient? Which one is the most efficient? Of course this one, right? I just tell you. F equation, right? If I want to solve the F a million.
You saved the best for the last.
Okay, if I want to solve F a million, how many zeros?
6.
How many zeros?
A million only has 6.
2, 4, 6. Okay. Yeah, a million. The previous one, F a million, needs to, if you want to solve F a million, what happened? You need to call F million, right? Then you will recursion call F million minus 1, F million minus 2, F million minus 3, until F0, right? Or you do it the bottom up way, the opposite way, F0, F1, F2, until you reach F million, right? It's going to take at least a million iteration. That's ON. But for this one, a million, I just calculate this. A million times half, plus a million times half, plus 1. Boom. That's it. That's O1. Mathematics. How do we get this? How do we get this? Because we plot this, right? Y, which is Fn, equals ax squared plus bx plus c. We know it's this equation. But how do we solve the ABC? We plug in the points. We plug in the point to this. When we plug in the points x, y, we have the equation for ABC. 3 unknowns. How many points we need to plug in to solve 3 unknowns? 3, right? Yes?
Yeah.
One equation we can solve one unknown, right? For example, 2 times a plus 100 equals 200. What's a? 2 times a plus 100 equals 200. What's a?
50.
Yeah, we know it, right? But if we have another b, like 2a plus b equals 10, you don't know a and b, there could be possibility, there could be combination, you don't know, right? But if I tell you another one, 3a minus b equals
Dang.
equals 5. Okay, so what's a, what's b? Then you know how to get it, right? You plus it together, that's 5a equals 15, and a equals 3, b equals 4, right? You know that, right? Now if I have another unknown c, 2a plus b plus c equals 10. 3a minus b plus c equals 5. 5a plus 2b plus 3c equals 100. Okay, so now with 3 unknowns and 3 equations, we can solve A, B, C. 4 equations and 4 unknowns. If we have another unknown D, do you get it? Yes? Yeah? So here we have 3 unknowns. So we need 3 equations. Where do we get the 3 equations? We just randomly select any 3 points, different points. Plug it in, we solve the equation, we get ABC. And then once we get ABC, we know for sure this is the equation for Fn. And once we have Fn, we just solve it. This is mathematics. O1 constant, time and space. Okay. That's it for today. What have you learned today?
About
Everyone?
pizza.
Pizza, cutting the cake, yeah. So we talk about this, right? So can you tell me just one important takeaway and that's it.
Cutting circle.
You use 0.5 times n
Squared.
F7 equals what?
29.
Yes, because f7 equals f6 plus 7. Okay, you know that. That's the equation. Fn equals fn minus 1 plus 7. This is quite similar to Fibonacci, right? Fibonacci is fn equals fn minus 1 plus fn minus 2. Okay. Okay, that's it for today. Bye bye. Bye bye.
Bye.
Bye bye.